In the previous class, we have discussed principal value branches of sin inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x. And the last one is cosecant inverse x. Okay, my dear Joseph, we can start recording. You can start recording.
Your voice is breaking, sir.
Voice is breaking. There is some like a technical error. Technical problems are there. Maybe in the devices. There may be in device. In the morning, I have posted the video of the morning class in the Google Classroom. Okay, my children. Okay, my dear children. Now, let us discuss principal value branch of Now we are going to discuss principal value branch of cosecant inverse x. Okay.
Okay, sir.
First, let us recall the domain and range of cosecant x. It is a defined set of all x such that x belongs to R and x is not equal to n pi. This is the domain of
Sir, your
cosecant
screen is zoomed in very much, sir.
screen.
It is zoomed in very much, sir.
Are the letters clear?
Letters are clear, sir, but your screen is like zoomed in, sir.
Sir, only half of your page is seen, sir.
No. Now is it okay?
Yes, sir.
Yes.
So this is the domain of cosecant x, set of all x such that x belongs to R and x is not equal to n pi. The x value should not be multiple of pi. And its range is R minus open interval minus 1 comma 1. Okay. But if you take this domain, it is not a bijective function. Now we have to change the domain of cosecant x so that this function become a bijective function. On the real number line, here also we divide this number line into different intervals so that cosecant x, the function cosecant x, become a bijective function like this. Minus 3 pi by 2 to minus pi by 2, that is one interval. We have to exclude this minus pi, because if you take minus pi, it is not defined. That is why we are excluding this value. Similarly, closed interval minus pi by 2, pi by 2 minus a singleton 0. If you take x value is 0, cosecant x is not defined. That is why we are excluding this number in this interval. Similarly, in this interval, closed interval pi by 2 comma 3 pi by 2, in this interval, if you exclude pi, if you take x value is equal to pi, cosecant x value is not defined. 1 by 0, we get 1 by 0, it is not a real number. That is why we are excluding this pi from this interval. If you take this interval as a domain, or if you take this interval as domain, or if you take this interval as domain, in all these cases, cosecant x is a bijective. Okay, my dear children. See here, suppose if you take domain, then the range of this cosecant x is or minus open interval minus 1 comma 1. Then in this case it is a bijective. If you consider this interval as a domain, in this case cosecant x is a bijective. Since it is a bijective in this interval, we can find its inverse. Cosecant inverse x. What, my dear Grayson? My dear Grayson, do you want to say something? Grayson?
No, sir. By mistake, I clicked.
Your mic is on. That is why I have doubt. I have doubt whether we are going to ask any question.
No, sir. By mistake, while writing, I wrote.
Okay.
Touch the mic
Okay.
button.
Okay. Here, if you observe these real numbers, we divided this real numbers set into different intervals. This is one interval. This is another interval. This is another interval. If you take this interval as domain of cosecant x, in this case, we get a bijective function. Range is the same, or minus open interval minus 1 comma 1. Since it is a bijective, in this case, we can find its inverse. Understood this point, my dear children? As we followed for the previous trigonometric functions, here also we follow the same rule. We are dividing, we are restricting the domain of the given trigonometric functions so that it becomes a bijective function. That is our main intention, to make trigonometric functions a bijective function. We are restricting the domain of the trigonometric functions. Then it automatically leads to find its inverse. Understood this point, my dear children?
Yes, sir.
So here different intervals, different branches. We call these intervals as different branches of cosecant inverse x. The above said intervals are said to be different branches. Flow interval minus pi 3 pi by 2. Closure interval minus 3 pi by 2 comma minus pi by 2 minus singleton set minus pi. Similarly, closure interval minus pi by 2 comma pi by 2 minus singleton set 0 comma closure interval etc. We get infinitely many intervals. Such many intervals we get here. These intervals are said to be branches, different branches of cosecant inverse x. These are called but especially this interval, closed interval minus pi by 2 comma pi by 2 okay, my children, especially closed interval minus pi by 2 comma minus pi by 2 comma pi by 2 minus a singleton 0. This interval, especially this interval is called principal value branch of cosecant inverse x, and this notation is read as cosecant inverse x or arc cosecant x. Okay, my children, will you read these two lines, all of you? Kevin Paul, my dear Kevin Paul,
Yes, sir.
read this one from here.
Closed interval minus pi by 2 comma pi by 2 minus singleton set 0 is called principal value branch of cosecant inverse x. Cosecant inverse x is read as cosecant inverse x or arc cosecant x.
Very good, Kevin Paul. Joseph, can you read these two lines?
Yes, sir.
Ah,
Closed interval of minus pi by 2 comma pi by 2 minus singleton set 0 is called principal value branch of cosec inverse of x. Cosec inverse of x is read as cosecant inverse x or arc cosecant x. So,
very good, Joseph. Jerome Jasliraj.
Okay, sir. The closed interval of minus pi by 2, comma pi by 2 minus the singleton set of 0 is called principal value branch of a cosecant inverse. So this notation is read as cosecant inverse of x or r cosecant x.
Very good, my dear Jiram Jasliraj. Grayson,
Yes, sir. Closed interval minus pi by 2, comma pi by 2 minus singleton of 0 is called principal value of branch of cosec minus inverse x, which is read as cosecant inverse x or arc cosecant x.
very good, Grayson. Preetika,
Yes, sir. Closed interval minus pi by 2, comma pi by 2 minus singleton 0 is called principal value branch of cosec inverse x. This is read as cosecant inverse x or arc cosecant x.
okay, last, Blessina.
So closed interval minus pi by 2, comma pi by 2 minus singleton set 0 is called principal value branch of cosec inverse x, which is also called as R cosecant x.
Very good, very good. So we have discussed principal value branches of 6 inverse trigonometric functions. Okay, my dear children. For these inverse trigonometric functions, you can see the diagrams in the textbook. For these 6 inverse trigonometric functions and trigonometric functions as well, diagrams also given, graphs of 6 trigonometric functions and their inverse trigonometric functions. Graphs of these functions were given in the textbook. Once you go through these textbook, these pages in the textbook. Okay, my children. So
Okay, sir.
now let us recall the values of some important angles as you have already studied: sine 0 degrees, sine 30 degrees, sine 45 degrees, sine 60 degrees, sine 90 degrees. Yes or no? In the earlier class you have studied. Now we prepare a table of domain and ranges of inverse trigonometric functions. Okay, my children, you have to remember this table. This table already given in the textbook. Just I am explaining again this table. Sin inverse x domain is closed interval -1 comma 1 and its range closed interval minus pi by 2 comma pi by 2. This is nothing but principal value branch of sin inverse x. Okay, my dear children. Similarly, cos inverse x. For this inverse trigonometric function, domain is closed interval -1 comma 1 and range closed interval 0 comma pi. This is also nothing but principal value branch of cos inverse x. Okay, my dear children. Next, tan inverse x. Domain. Tan inverse x domain is real numbers, set of real numbers. And here, and its range is open interval minus pi by 2 comma pi by 2. There is a lot of difference between closed interval and open interval. Closed interval means these endpoints also can be considered in that set, whereas in the open interval, in the case of open interval, these endpoints should not be considered as elements of that set. Okay, my children, understood this difference between closed interval and open interval?
Yes, sir.
Now come to the cot inverse x. Domain is a set of real numbers. And its range, open interval 0 comma pi. It is nothing but principal value branch of cot inverse x. Now come to the secant inverse x. Set of real numbers minus open interval -1 comma 1 and its range closed interval 0 comma pi, closed interval 0 comma pi minus singleton set pi by 2. And the last one, cosecant inverse x. Domain of cosecant inverse x is or minus open interval -1 comma 1 and its range closed interval minus pi by 2 comma pi by 2 minus singleton set 0. Okay, my children, this table already given in the textbook. Once you go through that textbook or okay, my children.
Okay, sir.
Now let us recall the trigonometric values, trigonometric function values of some well-known angles. Do you remember these angles, my dear children? These are well-known angles. 0, pi by 6 means 30 degrees. Pi by 4, 45 degrees. Pi by 3, 60 degrees. Pi by 2, 90 degrees. Do you know sine 0? 0. Sine pi by 6, 1 by 2. Sine pi by 4, 1 by root 2. Sine pi by 3 value, root 3 by 2. You have to remember these 5 values in the first row. After that cos value, just write in the reverse order. Write in the reverse order. 1, root 3 by 2. 1 by root 2. Next tan. How do you find tan value? Tan 0. Sin by cos. Yes or no?
Yes, sir.
0 by 1. 0. 1 by 2 by root 3 by 2. 1 by root 3. 1 by root 2 by 1 by root 2. 1. Root 3 by 2 by 1 by 2. Root 3. 1 by 0. Not defined. Next cot. It is nothing but reciprocal of tan x. Yes or no? Reciprocal of tan x. It is 0 by 1, so not defined. Its reciprocal is root 3. Its reciprocal is 1. Its reciprocal is 1 by root 3. Its reciprocal is 0. It is nothing but we just denote it as infinite symbol. Next secant x. It is a reciprocal of cos x. So reciprocal of cos x. 1, 2 by root 3. Root 2. 2. Okay, my children. Cosecant x. Reciprocal of sin x. Not defined. Not defined. 2. Root 2. 2 by root 3. 1. You have to remember these trigonometric values of these well-known angles. Okay, my dear children. We use these values in finding the inverse trigonometric function values. Okay, my dear children.
Okay, sir.
Sin x is equal to y. Sin x is equal to y. By implies sin inverse y is equal to x. We can write this trigonometric equation as inverse trigonometric equation. Okay, my dear children. When x values and y values should be like this only. These values. Okay. Sin inverse y means here y belongs to, when y belongs to and x belongs to, we can write this trigonometric equation as inverse trigonometric equation like this: cos x is equal to y. By implies cos inverse y is equal to x when x belongs to close interval 0 comma pi and y belongs to close interval -1 comma 1. Tan x is equal to y. This trigonometric equation can be written as tan inverse y is equal to x when x belongs to open interval -pi/2 comma pi/2 and y belongs to real numbers. Y is a real number. Cot x is equal to y. This trigonometric equation can be written as cot inverse y is equal to x when x belongs to open interval 0 comma pi and y belongs to real numbers. Secant x is equal to y. By implies secant inverse y is equal to x when x belongs to close interval 0 comma pi minus a singleton set pi/2 and y belongs to or minus open interval -1 comma 1 and last one cosecant x is equal to y. This trigonometric equation can be written as inverse trigonometric equation cosecant inverse y is equal to x when x belongs to close interval -pi/2 comma pi/2 minus a singleton set 0 and y belongs to or minus open interval -1 comma 1. Okay, my children. So from the trigonometric equations we can write inverse trigonometric equations, and when trigonometric equations are given we can write it as a trigonometric equation. Understood this point, my children?
Yes, sir.
It means if you observe minutely, x belongs to -pi/2 comma pi/2. There are positive real numbers, positive angles and negative angles -pi/2. Yes or no? Here x belongs to 0 to pi. Which quadrants? First and second quadrant. Yes or no? 0 to pi means 0 to 180 degrees. If you take Cartesian plane, Here we take 0. Here we take pi by 2. Here we take pi. Here we take 3 pi by 2. Here we take 2 pi. Okay. Yeah, and so on. If you take in the reverse order, 0 minus pi by 2. Here we take minus pi. Here we take minus 3 pi by 2. Here minus 2 pi. If you take in the clockwise direction, if you measure the angle in the clockwise direction, then 0, here minus pi by 2, here minus pi, here minus 3 pi by 2, minus 2 pi. So minus pi by 2 to pi by 2 means first and fourth quadrant. Close interval. The angle lies in the first and the fourth quadrant. Close interval 0, pi means the angle lies in the first and second quadrant. 0 here, pi is there in this. Yes or no?
Yes, sir.
Minus pi by 2, pi by 2 means here, from here, this angle. So first and fourth quadrant. 0 to pi means here. So first and second quadrant. Remember these points, my dear children. These points will help you in finding the principal values of given inverse trigonometric functions or values of inverse trigonometric functions. Now, shall we start the exercise? Shall we start today? Now the time is 4 past 15 minutes, my dear children. Shall we start exercise today or tomorrow?
Tomorrow, sir. Again, please start tomorrow, sir.
Okay, my dear children. In the meantime, please watch the video again. Please watch the video again. Write the classwork notes. Somebody are not writing classwork notes. Please take it serious. Without classwork notes, how do you study? How do you learn the subject? Yes or no? Without classwork notes, you can't study. You can't improve your subject. Yes or no, my children?
Yes, sir.
So, please give importance to writing the classwork notes and submit your classwork notes in the Google Classroom and watch the videos every day. I'm telling you, every day. Watch the videos completely one more time. After school time is over, again watch the video every day regularly. Spend 45 more minutes. Okay, my dear children. Now you can leave the meeting. Take rest. Take care of your health, my dear children. Stay at home.
Thank you, sir.
Thank you, thank you,
Thank you,
Kritika.
sir.
Thank you,
Thank you, sir.
Joseph. Thank you, Joseph. Thank you, Blessina.
Thank you, sir.
Thank you, Kevin Paul.
మళ్ళీ కొట్టేస్తా నీ మాట వినట్లేదుగా నీ మాట వినట్లేదు కదా
తప్పునా వింటారులే చిన్నపిల్లలు కదా నీలాగా
పెద్దోళ్ళు 12th క్లాస్ వచ్చారు పెద్దోళ్ళు
వాళ్ళ పేరెంట్స్ వాళ్ళు చిన్నపిల్లలే కదా వాళ్ళ పిల్లలు పేరెంట్స్
అందుకని
వాళ్ళ పేరెంట్స్ కి వాళ్ళు చిన్నపిల్లలా కాదా
అవును,
అందుకనే నేను చెప్తున్నాను చిన్నపిల్లలు అని.
కానీ నువ్వు అంటే వీడియో వాచ్ చేయమంటావు కదా, వాళ్ళు నీ మాట వినట్లేదు కదా, ఆడుకుంటూ ఉంటారు కదా.
అందుకని అరుస్తున్నాను, గట్టిగా చెప్తున్నానుగా.
మరి వాళ్ళు చిన్నపిల్లలు కాదుగా, పెద్దవాళ్ళు కదా.
రోజు వాచ్ చేయండి.
వాళ్ళు పుట్టిన పిల్లలు అయితే చిన్నపిల్లలు అనుకోవచ్చులే, వీళ్ళు పెద్దోళ్ళు.
అవును,
నువ్వే చెప్తావుగా చిన్నపిల్లలని.
వాళ్ళ పేరెంట్స్ వాళ్ళు చిన్నపిల్లలే కాదా.
మరి నీ క్లాస్ అంటే మరి నీ క్లాస్ అప్పుడు చిన్నపిల్లలేనా నీకు?
కాదు, అరుస్తాను అప్పుడు.
డాడీ నేను చెప్తా,
చెప్తూ ఉండు.
టిక్కొట్టినేనా?
టిక్ కొట్టిన వరకే.
ఏంటి ఈరోజు అంతమంది వచ్చారు?
తక్కువ మంది వచ్చారు ఈ పూట.
మార్నింగ్
ఇది స్పెషల్ క్లాస్ కదా నాన్న, అందుకని వాళ్ళ ఇష్టం అయితే వస్తారు, లేదంటే లేదు. మార్నింగ్ అయితే బాగా వస్తారు.
మార్నింగ్ తప్పకుండా రావాలి కదా. చెప్పనా?
చెప్పినాను. బ్లెస్సీనా, గ్రీసన్,
జోరోమో జెస్లీరాజ్,
జెస్లీరాజ్,
జోసెఫ్,